For centuries, these deaths went down as unsolved, not because science refused to look, but because it had not caught up. A composer's hair carrying extraordinary levels of lead, cats spinning beside a poisoned bay, a Rhode Island grave that seemed to confirm a vampire. One case resists an answer, and the last ends with a model, not a verdict. The composer's last bottle. The wine beside Ludwig van Beethoven's bed was cheap and sweet. March of 1827 found the 56-year-old composer dying in Vienna after years of deafness, stomach trouble, and worsening liver disease. Doctors had proposed many explanations for his hearing loss, while lead exposure remained only one possibility among several. Lead compounds were historically used to sweeten or clarify some wines, and researchers have also suggested food and medical treatments as possible sources of Beethoven's exposure. The mechanism is bioaccumulation, a buildup that happens when a substance enters the body faster than it leaves. Imagine coins dropped into the wrong jar day after day. The amount grows even when each deposit is small. Scientists tested 2 authenticated locks of Beethoven's hair in 2024 and found extraordinarily high lead concentrations, dozens of times above modern reference levels. The results showed severe lead exposure, but it did not establish wine as the source or lead as the sole cause of his deafness. Genetic work had already found a strong predisposition to liver disease and evidence of hepatitis B infection. Beethoven died that March, with cirrhosis long considered the most likely immediate cause. The hair changed the medical picture without turning one clue into a single answer. The cats who warned first. Minamata Bay had fed fishing families for generations before the same food began making them ill. In 1956, 2 sisters aged 5 and 2 became the first officially reported patients with the strange neurological disease. Their loss of coordination and convulsions initially looked like a local outbreak with no known cause. Cats had shown something was wrong earlier, staggering, convulsing, and dying after eating scraps from the bay. The missing mechanism was biomagnification, the rise in a contaminant's concentration as one animal eats many contaminated organisms below it in the food chain. Picture the contents of many small jars being poured into one larger jar, so each predator collects mercury from many prey. Industrial wastewater had carried methylmercury into the sea, where it accumulated in fish and shellfish eaten by local families. 2-year-old Jitsuko Tanaka was hospitalized with the same disease and survived for decades with severe neurological damage. In September of 1968, Japan's government formally concluded that methylmercury compounds in factory wastewater had caused Minamata disease. The cats had not diagnosed the poison, but their behavior was an early warning from the same contaminated food chain that was harming people. The Sweat That Killed by Supper. William Carey left for a hunt in June of 1528 as a healthy 37-year-old courtier in Henry VIII's household. Within hours, he was struck by chills, heavy sweating, exhaustion, and a rapid decline. Contemporary accounts treated sleep during the illness as a terrifying sign, and Carey died the same day. England had seen repeated waves of the sweating sickness since the late 15th century, with that year's outbreak reaching the royal court and then parts of continental Europe. Its cause remains unknown. One modern hypothesis points to a hantavirus, a rodent-borne virus that can spread when contaminated particles become airborne. The process is a zoonosis, an infection that passes from animals to humans. Flour shaken from an open bag gives a simple comparison. Fine particles can hang in the air and be inhaled without anyone touching the source.
That model can explain why rodent exposure has been discussed, but no preserved sample of the original pathogen exists. The sweating sickness, therefore, has a plausible modern candidate, not a solved diagnosis. Carey's death shows the speed that made the disease so feared, while the missing biological evidence is exactly what keeps the case open. Awake inside a dying body. Early European accounts from the Amazon described hunters and soldiers becoming completely paralyzed after wounds from poisoned arrows. The poison, later called curare, could stop voluntary movement and breathing while leaving the heart beating, a pattern Europeans struggled to explain. In 1814, naturalist Charles Waterton, then about 32, helped test the poison on donkeys in London with 2 medical colleagues. One animal collapsed after receiving curare, but the team kept it alive by forcing air into its lungs for roughly 4 hours until the paralysis wore off. Waterton lived for more than half a century afterward and died in 1865 at 82. Later experiments showed that curare acts at the neuromuscular junction,
the handoff point where a nerve tells a muscle to contract. A loose plug in a socket gives the comparison. The signal reaches the end of the wire, but the appliance never receives enough current to run. The brain can keep issuing the command to breathe, while the respiratory muscles fail to act on it. That mechanism turned an old arrow poison from a mystery into a specific problem of blocked nerve-to-muscle signaling. The girl they called a vampire. Neighbors in Exeter, Rhode Island believed that tuberculosis deaths inside one family could mean that someone already buried was harming the living. During March of 1892, 19-year-old Mercy Brown had already died after the same wasting illness that had taken her mother and sister. Her surviving brother was also sick, so relatives and neighbors agreed to examine the dead. Mercy's body appeared unusually well preserved, and blood remained in her heart. To the people present, those ordinary post-mortem findings looked like evidence that she was somehow still active. Her heart was burned, the ashes were mixed with water, and the mixture was given to her brother. He died 2 months later. Mercy's preservation had a simpler mechanism. Her body had spent the New England winter in an above-ground receiving vault, while the soil was too frozen for burial. Cold storage works like a refrigerator, slowing the processes that break tissue down. The medical term is putrefaction, the post-mortem breakdown of tissue, driven largely by microbes and chemical reactions. Mercy had been dead for only about 2 months in unusually cold conditions, while her relatives had been buried for years. The family's real disease was tuberculosis, spreading among the living rather than returning from the grave. The man who looked asleep. Bjelskodalbo, near Silkeborg, Denmark, yielded a human face in May of 1950, and the peat-cutting family called police, convinced they had found a recent murder victim. The body became known as Tollund Man. Modern dating places his death between about 405 and 380 BC, and researchers estimate he was roughly 30 to 40 years old. A leather cord around his neck and the autopsy evidence indicate that he died by hanging. His closed eyes, stubble, skin, and even intestinal contents survived for more than 2 millennia. Danish police analyzed a preserved thumbprint in 1976. His last meal was a porridge based mainly on barley, flax, and wild seeds, with later analysis also finding fish. The preservation mechanism is an anaerobic acidic environment, meaning very little oxygen, plus bog chemistry, that slows the microbes normally responsible for decay. A cold, sealed tanning vat gives the closest comparison. The chemistry preserves skin instead of letting ordinary decomposition proceed. Whether Tollund Man was executed or ritually sacrificed remains uncertain. Museum Silkeborg considers sacrifice a reasonable interpretation, but the evidence cannot identify his motive or social status. His cause of death is clearer than the reason for it. A heart sealed in brandy. Frédéric Chopin feared being buried alive and asked that his heart be removed after death. By October of 1849, Chopin was 39 and gravely ill in Paris after years of respiratory disease. His sister Ludwika carried the preserved heart to Warsaw, where it was placed in a church column. Tuberculosis had long been suspected, but later writers also proposed inherited disorders, such as cystic fibrosis. A Polish team examined the sealed heart macroscopically in 2014 without opening the jar or sampling the tissue. The findings were published and discussed in later medical work. Researchers reported changes strongly consistent with long-standing tuberculosis and tuberculous pericarditis, inflammation of the sac surrounding the heart. Heat passing through rooms that share a wall gives a useful comparison. Disease in nearby structures can reach the pericardium and interfere with cardiac function. The examination could not genetically rule out every alternative diagnosis, but the visible pathology supported tuberculosis as the primary disease and pericarditis as a possible immediate cause. Chopin died in Paris that October. The preserved organ narrowed a century-old argument without requiring the one surviving specimen to be opened. The plague with no name. Athenians crowded behind their city walls during the Peloponnesian War as a violent epidemic moved through the population. In 429 BC, the roughly 66-year-old statesman Pericles fell ill after losing both legitimate sons to the same outbreak and died later that year. Thucydides left the most detailed surviving description, including fever, thirst, skin lesions, and unusual animal behavior around the dead. For centuries, the pathogen remained unidentified. Researchers reported ancient DNA from teeth in a mass grave in 2006 and interpreted it as evidence of typhoid fever. Other scientists challenged that conclusion, arguing that the genetic evidence did not prove typhoid. A newer 2026 review proposed invasive non-typhoidal salmonella as a better fit, but that remains a hypothesis rather than a recovered pathogen. Ancient DNA is genetic material preserved in old remains. A damaged photocopy gives the analogy. Surviving fragments must be matched carefully before anyone can name the original document. Crowding inside the walls likely amplified transmission regardless of the exact organism. Pericles' death is documented. The identity of the epidemic that killed him remains unsettled. The night the snow came down. Wind loaded the slope above the Dyatlov group's tent during the night of February 1st into 2nd, 1959. 23-year-old expedition leader Igor Dyatlov and 8 companions left the tent in extreme cold without enough clothing, and all 9 died. Dyatlov's autopsy attributed his death to hypothermia. The damaged tent and severe injuries in several group members helped fuel decades of theories about what forced them outside. Engineers Johann Game and Alexander Puzrin published a model in 2021 showing that a delayed slab avalanche was physically plausible. A slab avalanche is a cohesive plate of snow that breaks loose above a weaker layer. Their model combined a cut made in the slope for the tent with wind-driven snow loading over several hours. An overloaded shelf gives the household analogy. It can stay up after being weakened, then fail only after more weight is added. The study established plausibility rather than the exact sequence that night. Follow-up expeditions later documented avalanche-prone terrain and small slab avalanches in the Dyatlov Pass area, including one less than 3 kilometers from the tent location. No evidence identifies which hiker cut the tent. The avalanche explanation fits important clues, but the final reconstruction remains a model rather than a witnessed event. Which explanation surprised you most? Tell us in the comments, and subscribe for more historical medical mysteries science has narrowed down.